So this is a chemical energetic exercise, structure questions. So in the first question, sulfur tetrafluoride, which is SF4, can be made by combining a gaseous sulfur with fluorine. The equation is shown that a gaseous sulfur mixed with 2 moles of fluorine to give sulfur tetrafluoride. The reaction is exothermic. We have to complete energy diagram, include an arrow which shows the energy change during the reaction. So first we have the reactant. The reactants are there, sulfur and fluorine, and it is forming SF4. So which one will have high energy, reactant or product? The reaction is exothermic. So which one will have high energy, reactant or product?
Product, no, reactant.
Reactant. Because in exothermic, reactants have high energy and the product is having low energy. So when we draw for product, we will draw downward. Like the position of a product will be below the reactant. So the product is SF4 in a bracket. This G is actually representing the state symbol of a product that is in a gaseous state. So we just have to label the energy change. We have to draw, because we have to complete and draw an arrow which shows the energy change. So arrow of the energy change is always from reactant to product. So the arrow must point downward, and you will label that. If you can write delta H, which means enthalpy change or energy change, or you can also label this arrow as energy change. And if the same question was there, because they did not ask for activation energy, but if the question was label activation energy as well. So this example is a point where the reactions start. So minimum possible energy from reactant till the start of a reaction, what we call that as activation energy, and you can label that as EA, where E stands for activation and A stands for energy. So delta H pointing down and activation energy is upward. Is it clear, this figure, how we work out? Any question or a doubt? The next part, we have to, during the reaction, the amount of energy which is given out or released is 780. The fluorine bond energy is 160. Use the information, we have to find SF bond. Here in sulfur, there is no bond, so there is no bond energy, like it is 0. For fluorine, it is 160. This is 160, 160. And this is the reactant side. So reactant side is always a bond breaking side. And SF4, that is the bond forming side. Now, remember the formula that the bond breaking energy minus the bond forming energy is equals to energy change. Or enthalpy change equals to bond breaking minus the bond forming. The bond breaking minus the bond forming is equals to energy change. The bond breaking energy, that is 160 multiplied by 2, because the two bonds which we are breaking, each is 160. So it will be 160 times 2. Minus the bond forming energy, that is we are finding. So if I say this is X, this is also X, this is also X, and this is also X. So how many bonds are forming? 4 SF bonds are forming. So we can say 4X. Or you can also write 4 SF. Like 4 bonds of SF are there. The both ways are fine. equal to energy change. What is the energy change? 780. But remember, the energy is given out. So whenever energy is given out or the reaction is exothermic, so energy change will be negative. So we'll write as minus 780. So if you write plus 780, you will get a wrong answer. It's important that you write a correct answer according to the question. So as I mentioned, energy is given out, then energy change is negative. If energy is taken in or absorbed, the energy change will be positive. So 2 multiplied by 160, that's 320. This is 4 SF equals to minus 780. This is 320. It is positive like sign. It will move other side, will become negative. So 4 SF bonds equal to minus 780 minus 320. So minus 780 minus 320, that sum will be minus 1100. So minus 1100 and 4 into SF. So if you want SF bond, this minus 4 is multiplied, other side will be divided. So S and F bond energy will be equal to minus 1100 divided by minus 4. So minus 1100 divided by minus 4, so that will come out as 275 kilojoule per mole. The final answer is 275 kilojoule per mole. Is it clear, this example? So why it was 2 into 160? Because this is one SF bond, 160 is there. This is another, this is one fluorine bond, 160, another fluorine bond, 160. And for sulfur, there is no bond, like it's a sulfur atom, that's why it was 0. So the bond breaking energy minus the bond forming energy equal to energy change. Another question. So iodine react with chlorine. The chemical equation is shown. Use the bond energies to answer these questions. The total amount of energy required to break bond in 1 mole of iodine and chlorine. So 1 mole of iodine, because I2 means iodine single bond is there, and Cl2 means chlorine single bond. So for iodine it is 151, and for chlorine it is 242. So when we substitute the values, iodine is 151 and chlorine is 242. So when we sum them, this will give us how much energy is needed to break the bond. So 151 plus 242, that is equals to 393. So 393 or 393 is there, the energy needed to break the bond. Then calculate the total amount of energy given out when 2 moles of ICl are formed. When 2 moles or 2 molecules of ICl are formed here, it means INCl and INCl. When one bond is formed, amount of energy is 208. But there are 2 bonds are formed, like 2 bonds of ICl, so it will be multiplied by 2. So 2 multiplied by 208 multiplied by 2, that's equal to 416. So 416 is the amount of energy which is released when these 2 bonds are formed. So one is a bond breaking energy, the reactant side, and the product side is a bond forming energy. The next part, we have to calculate the energy change. Use your answer to D1, calculate the overall energy change. So what is the formula for energy change? Like this was 393 and this one is 416. So the formula for calculating the energy change, it is bond breaking minus bond forming, that is equals to energy change during a chemical reaction. So this one, reactant side is a bond breaking and the product side was a bond forming. So bond breaking energy is 393 minus the bond forming energy is 416. So when we subtract, this will give us the energy change for this reaction. So 416, 393 minus 416, that's equal to minus 23. So energy change for this reaction equals to minus 23 kilojoule per mole. Because we are getting a negative answer, so what is the significance of negative answer? Negative answer shows that this reaction will be exothermic. Is it clear? Another question, the reaction of cyclopropane with bromine is exothermic. Exothermic reaction means reactants have high energy and the product is having low energy. So cyclopropane react with the bromine to give dibromopropane. We have to complete energy diagram by adding the product and the label for energy change. Because they already mentioned that this reaction is exothermic, like this part, that this reaction is exothermic. These are the reactant, cyclopropane and bromine are the reactant. So what will be the product here? The product is dibromopropane. So when we draw, like show the position of a product, dibromopropane, it should be below. Because the reaction is exothermic, so it should be below. If the reaction is endothermic, like same question was there, and they say the reaction is endothermic, then we'll draw that above. And we will write, because they write the name, so we don't have to write a formula, we will write the name of the product, that is dibromopropane. Then we draw by adding a product, add the product we did, and then label the energy the change. So if you want to draw an arrow to show the energy change, it is always from reactant to product. So for exothermic reaction, the energy change or enthalpy change is negative, or the arrow is also always pointing downward. So energy change or delta H is downward. The arrow is pointing downward. And if the same question was there, they did not ask for activation energy, so you don't have to. But what if there was a question, label activation energy? So you will mark a position where the reactions start and complete from reactant to product and draw an arrow from the start of the reactant till the start of reaction. So that energy is known as activation energy. But in this question, there is no need for marking an activation energy, as they only ask for product and the energy change. The next question, we have to calculate the energy change for this reaction in which a propene reacted with a bromine to give dibromopropane. So remember, the reactant side is always a bond breaking side, and the product side is a bond forming, and bond breaking minus bond forming will give us energy change. So bond which we are breaking, so identify the bond which you are breaking, the common bond, like 1CH, 2CH, 3CH, 4CH, 5CH, and 6CH bonds are there. So there are 6 CH bonds. That is a bond breaking side. Plus there is carbon double bonded with carbon is there. And carbon, remember, carbon double bond with carbon is a different thing. And carbon single bonded with carbon is another, like a different energy. So carbon single bonded with carbon, and then bromine is also there. So bromine single bonded with bromine. Then we can substitute the values. So this will be 6 multiplied by carbon and hydrogen bond energy is 412. Plus carbon-carbon double bond is there, that is 611. Plus carbon-carbon single bond is there, 348. Then bromine-bromine single bond is there, 193. So we'll just sum them, like add them to get the bond energy. So when we add the total bond energy or the bond breaking energy will be 3624. That's a bond breaking energy. Now the bond forming energy. So first we'll identify what bonds we are forming. So 1 CH, 2 CH, 3, 4, 5, and 6 CH bonds are there. So 6 into CH. Plus CC bonds are there, 1 and 2. So 2 carbon-carbon bonds are there. And then CBr bonds are there, carbon and bromine bonds, 2 of them. So 2 carbon and bromine bonds. Then we substitute the values. So 6 multiplied by 412 plus 2 multiplied by carbon-carbon single bond, that is 348, plus 2 multiplied by CBr, which is 285. So when we sum them, this will give us the total bond forming energy that will come out as 3788. So bond breaking energy we have, bond forming energy also we have. Now we need the energy change. So how to work out the energy change or enthalpy change? So energy change is equals to bond breaking minus bond forming. The bond breaking energy is 3624 minus bond forming 3788. 3738, not 88. This is 38. So when we substitute, like solve, it will give us minus 114 kilojoule per mole. So the energy change for this reaction is minus 114. So if the energy change is negative or enthalpy change is negative, what this gives an idea about the type of reaction? Is it endo or exo?
Exo.
So this is an exothermic reaction because the energy change is negative. So simple mathematical equations, like mathematical equation, you solve these type of question. Identify how many bonds are there in the reactant side, how many bonds are formed in the product side, and just the difference will give us energy change. In this question, the chemical equation for a complete combustion, burning is always exothermic. So when we burn ethanol, it gives carbon dioxide and water. The energy released, 1 mole of ethanol undergo a combustion, that is 1280. That's the energy change or energy released. The part of a diagram, the energy level diagram for this reaction is shown. Complete the energy level diagram, the product of the reaction. So where the product I will make, because it is an exothermic reaction, so the product should be down. Reactant will have high, and what are the product? 2 molecules of carbon dioxide and 3 molecules of water. So it will be 2 molecules of carbon dioxide and 3 molecules of water. So we have the product. Then we have to label overall energy change for this reaction. So overall energy change from reactant till the product, and how much is this? 1280. And why I write negative here? Because for exothermic reaction, the energy change is always negative. We can complete a diagram by connecting this table. What does X represent? What is the significance of X? What is this X?
Activation energy.
X is the activation energy, or this is the minimum possible energy for reaction to start. So we can say activation energy or minimum possible energy to start up the reaction. Is it clear? Okay, another question, same, which we need the bond breaking energy and the bond forming energy, and then we need the energy change for combustion of methanol. So first we have to identify the total bond which we break. So the reactant side is always a bond breaking side. So the bond breaking CH, CH, CH. So the bond breaking, the bond energy needed to break the bond of bond breaking CH. 3 are there, but that 2 is multiplied with 3. So total will be 6 because it means 2 molecules of methanol are there. So 1 molecule of methanol contains 3 CH bond. 2 molecules will contain 6 CH bonds plus CO. But how many? 1 molecule contains 1 bond. So 2 molecules will contain 2 CO bonds. Then OH, 1 molecule contains 1 OH bond, so 2 molecules will contain 2. And O double bonded with O, and that is multiplied by 3. So it will be 6 into the CH bond energy is 410. Then 2 into CO bond energy, that is 360. Plus 2 into OH bond energy, that is 460. Plus 3 into O double bonded with O, that is 500. So we sum to get the bond breaking energy. So the total energy which is needed to break the bond, that is 5,600. So 5,600 kilojoule of energy is needed to break the bond. So it's important that you identify how many bonds are there and total number of molecules. The second part, energy released when the bonds are formed. So you have to identify how many bonds are formed. OC or CO is the same thing. So if I write OC or CO, means 1 molecule, there are 2 CO or OC bonds. But in 2 molecules, there will be 4 OC or CO bonds. Same thing, in 1 molecule, there are 2 OH or HO bonds. In 4 molecules, because if there are 2 here in 1 molecule, so in 4 molecules, there will be 8. So this will be multiplied by 8. So it will be 4 into CO, that is 805, plus 8 into OH bond, that is 460. When we solve, this will give us the bond forming energy, which is 6,900. So this energy will be 6,900 kilojoule. The next part, we need the energy change for this reaction. So this was the bond breaking energy, 5,300, 6,900. The formula for energy change, that is a bond breaking minus bond forming. So reactant side is always a bond breaking energy and the product side is a bond forming. So 5,300 minus 6,900, that will give us 1,600, and that will be, sorry, this 5,600 was there, not 300. This 5,600, so this will be 1,300 kilojoule per mole. And in the question, we need for 1 mole. So how we, like 1,300 is there, but if you see the equation, if you check the equation is for 2 moles. When in the question they highlighted if we burn 1 mole of methanol. This equation is for burning 2 moles of ethanol. Yeah, minus 1,300. This equation is for burning 2 moles of methanol. You can see here, like this compound is called methanol, and how many moles we are burning? 2. So if we burn 2 moles of methanol, the energy change is minus 1300, 1300. But in the question, the last part, they're not asking for 2 moles, they specifically ask for 1 mole. So if for 2 moles when we burn, it is minus 1300. But if we need for 1 mole, because in the equation there were 2, so we divided by 2, it will give us minus 650 kilojoule per mole. Is it clear? So reason for dividing the last value by 2, because in the first part we were having like in the equation we were having 2 moles of methanol, so energy change we calculated for 2 moles, but in the question they did not ask for 2, they're asking for 1, that's why we divided by 2. So we calculate for 2 moles, like we calculated the energy change. So this is 5600, this was 6900. When we calculate, 6900, when we calculate a difference 1300. That is correct, but because they asked for 1 complete, that's why it is divided by 2. So these are some questions related to topic enthalpy change and energy change.